Hello, it's Carly McAvoy. I'm talking about perimeter and area today. This is the second part of the activity 2 from the geometry packet in Math 107, but anybody can look at this and understand a little bit more about perimeter and area. This is not a basic perimeter and area video because this is assuming that you've seen this before in your prerequisite skills, but just a quick reminder, perimeter is the distance around an object. So for us, I'm just going to say add up all the sides, and that's going to be how you find perimeter. But you may talk to some instructors who say, well, there's specific formulas for different type of shapes, which there is. But what I'm going to do is just say add up all the sides. That's going to give you the perimeter. That's only one thing to remember. The area is, and also the perimeter is linear units, which means units to the first power. Area is the measure of the region inside the polygon. Area is measured in square units or units to the second power. The table below shows the formulas used to find the area for a variety of shapes. Also in this table, as you have it in front of you, if you printed out the notes, there's an example. So this one says in a square, we say that there's each side, and we have those little marks, which means that they're all congruent or the same length. And so we just say it's side times side, which is side to the second power. If a side was 3, it'd be 3 times 3. But notice it would be inches to the second power because area is always to the second power. In general, for rectangles, which a square is a rectangle, we say length times width. If I had 10 times 5, I would get 50, but I would get centimeters squared. Notice my units squared, not the number squared, but the units squared. That's how you would write that. Again, this is a very quick review. So what about a triangle? Well, a triangle is 1/2 the base times the height. We could call this base and height, and some books do. Base times height is kind of a standard way to talk about things. But for a triangle, we're then cutting that in half. So if you had 4 times 3, if your base and your height were 4 and 3, 4 times 3 is 12, but then divided by 2 is 6. We still have meters squared because it's area. Now, why is it that we divide that by 2? We don't divide any of the other ones by 2. Well, let's look at a parallelogram. Parallelogram just means that you have the opposite sides are parallel, and we don't have right angles necessarily. Although we could have right angles, this could be a parallelogram because by definition, opposite sides are parallel. But when opposite sides are equal and parallel, we can get a rectangle otherwise, and we have these 90-degree angles. If we don't have 90-degree angles, we just can call it a parallelogram. And the formula is base times height. That is, whatever your base is and whatever your height. Notice the height is some dotted line that just shows you the distance between those two bases, more or less. Well, if I was to draw what was missing here, I actually have to draw something. What you should see is that a triangle is always half of a parallelogram. If I redrew this and flipped it over and drew it, I would have a full parallelogram. And the formula for a full parallelogram is base times height. But I have half of a parallelogram. That's why it's base times height divided by 2, because it's half of a parallelogram. That starts to make sense, and the triangle, remember, has the least number of vertices and least number of sides, so that makes you remember that's the one you want to divide by 2. Anyway, if I do parallelogram base times height, I get 119 yards squared because it's area no matter what the shape is. And the last shape is a trapezoid, and the trapezoid is big base plus little base. That is, you have a long base here, you have a shorter base here. And what I'm really interested in is the average. What's the average between those two? If I was halfway up, how wide would it be? And to find the average, you take the two, add them together, and divide by 2. That's just the average width of this thing. That's what that is. And then I multiply that times the height. So if I had a big base of 5 and a little base of 3, and I would add that and get 8. 8 divided by 2 is 4, and 4 times 4 is 16. Remember that The subscripts just mean we have two different things and we're naming them 1 and 2 just to keep them like thing 1 and thing 2, right? Just to keep them separate. That doesn't mean anything mathematically except that we have more than one base in this problem. Up here, these bases are the same, so we can just talk about it as plain old B. But here, because they're two different lengths, we need those subscripts. Okay, well, if finding the perimeter or area of an object is a useful skill that you eventually need to call upon if you live on your own, whether you live in an apartment or you live in a house or you live in a trailer, whatever it is, like a mobile home type of thing, you need to fix something or do something or whatever, you're eventually going to need perimeter or area skills. Artists, carpenters, welders, maintenance people, electricians, landscapers, do-it-yourselfers, anybody who wants to paint it, carpet it, line it, weld it, cover it, fence it, trim it, clean it, wire it, build it, or refinish it is going to need to know what they're working with. How big is the space that I need to refinish or that I need to buy carpet cleaner for or whatever it is? You have to kind of know the area size of your room. If you don't make a good estimate on the area and perimeter you're working with before you buy your supplies, you could spend a lot of extra money, or you could make a lot of extra trips to the hardware store. Being good at math makes you more efficient. So there's a reason that we want you to be able to make these estimates, and that is because you really do become a better consumer if you know exactly how much you make. Now, let's say that you want to find the perimeter and area of something, and you want to go out and buy tile, and this tile store is going out of business. So you know all sales are final. If you buy too much, you're going to be stuck with this stuff. And also, if you don't buy enough, you can't go back and get the same thing for sure because the store is going to be closed. So it makes it worth your while to make sure that you are buying the amount that you need the first time. And so, it'd be nice if all the problems in real world look like math book problems. Again, if you're struggling with perimeter and area, you should go and do some practice problems on regular polygons. But what we're doing is looking at, beyond that, the messy problems that you see in life. As soon as we have our regular polygon skills down, we find we rarely encounter regular shapes in our real life. We keep finding things, a cabinet that's got a weird bend in it and that kind of thing. And this leads to estimation, which is helpful. But if we can find the exact amount plus a little extra for waste, we can be the most efficient. Sometimes it's not possible, sometimes it is. So I have two examples for you. Both of these examples I took off of the internet. So these are things I went on and went like weird shaped rooms or odd shaped rooms, and these came back people saying, help, I got this weird shaped room, what should I do with it? This is the first one. Now, when I found these things off the internet, there was no guarantee that they were drawn to scale. But this one is pretty good because it's on graph paper, and that means the squares, if the squares are equal the same, that might be the same, but I don't really know. And so I'm going to assume that they're not drawn to scale. And even I can see this. This entire thing up top is 4. This is 2, which means these other two parts should be equal to 2. But if I add 1.56 and 0.43, I get 1.99. So already I'm missing 100th of something there. So I can see it's not perfect, but I'm going to do my best. Now the perimeter is the easy part. You're going to be asked to find the perimeter and the area. Perimeter, I'm going to start right here, and I always put a little arrow where I start to make sure I get all the sides. I'm going to add these up, and the ones that have 0.00 after them, I'm just going to put that as a 4 for now, but I'm going to put my final answer to 2 decimal places because that's how specific they were as they went around. 4, 3, 1.56, 3, 2, 2.5. This is the kind of work I want you to show on your paper. Just show me what you added up. 0.43 is this little bit right here. 3.5. And then I'm back to where I started. So I got everything, and then I can wave a magic wand and tell you that I added these earlier and got 19.99. And what's my unit? Well, these are all in meters, and this is linear, so it would just be 19.99 meters would be my answer for the perimeter. Now for the area, a little more complicated because the area is not cut up in a great way. So I'm going to have to divide this up. I can see that I have this little piece, and I'm going to also draw a line across here. And now I want to think about this as, here's my first rectangle, here's my second one, and here's my third one. And I have 3 rectangles that I can add together. Now what's the area of this? Well, it's 4 by 3. So for number 1, I've got 4 times 3. Again, I'm going to go to the 2 decimal places at the end because I have that. And then I'm going to add the second one. Well, the second one's a little trickier, but this came down to 3, and this one was 3.5, so I'm going to call this 0.5, 0. And what's this one? Well, it was 4 across all the way, and if I take 4 minus 1.56, then I get 2.44. So I'm calling this 2.44. Therefore, to find the area, I'm going to take 0.5 times 2.44. And I could have left that 0 off, but I didn't. And then I have the third part. And the third part is, well, this was 3 all along, but it's here. So it's 2.5 times 2. And now I'm going to multiply each of those things out and add them together. This is going to be 12. I'm going to add the 2 decimal places here. 2.44 times 0.5 is 0.122. And 2.5 times 2.0 is 5. And when I add all those together, I get 18.22 meters to the second power. So I feel like this isn't that much of an approximation. I feel pretty good about it. I'm going to do another video where I do one that's harder, but this one's already gotten long enough, this video, so I'll come back and do another one in a minute. See you in a bit.